So now I want to show you a couple examples of finding Taylor polynomials. So remember, Taylor polynomial, T sub n, is defined to be, right, so I'm using summation notation. I have my dummy counter, j goes from 0 to n. So I have these coefficients, right? These are just going to be numbers, coefficients. So it's the jth derivative evaluated at, right, the value a divided by j factorial times x minus a to the jth power. So we say this is centered at a. Remember, if 0 factorial, is 1, and the 0th derivative just means the function itself. All right, so first one we have, so f of x is cosine 2x. We're going to find the 8th polynomial, so the 8th order polynomial, and we're going to let a equal 0. Okay. All right, so right, the x part, the variable part, is not bad, but it's those coefficients that might take us a little bit of time. So let's go ahead and do a table for our coefficients. Okay. So I'll make a column here for my n's. And then I'm going to zoom in a little bit here. Let me scooch, zoom, better zoom. I need a better camera. All those things. Okay, so my n is going to go up to 8. Oh dear. Okay. I need that nth derivative, and let's just find it at x. Okay. And then let's do the part where we actually find the coefficient. So this last column here is going to be our coefficient. So it's going to be that nth derivative evaluated at 0, and then divided by n factorial. Okay? All right, so let's see what we can get. There we go. Okay, so the 0th derivative, remember, is just our function. So that'll just be cosine 2x. So cosine of 0, get my little unit circle, so I remember cosine of 0 is 1. So I'm going to have 1 over 0 factorial. So that's going to be a 1. Nice. Okay, n equals 1. That's the first derivative. So the derivative of cosine, do my little cheat sheet over here. Oh, I guess I'll do it right here so you can see it. So I don't know if you guys have seen my cheat sheet or not, but sine, cosine, negative cosine. Going down is differentiating. So derivative of cosine is negative sine. So I'll have negative sine 2x. Oh, but then chain rule, so 2. Okay. At x equals 0. Sine of 0 is 0. So that one's just 0. Oh, okay, sweet. N equals 2. So now we do the derivative of negative 2 sine x. So the derivative of negative sine is negative cosine. So I'll get negative, I'll get the extra 2 for cosine 2x. Okay, plug in the 0. Cosine of 0 is 1 times negative 4. So negative 4. Third derivative, derivative of negative cosine, loop back up. Sine, extra 2. So that'll be, oh, positive. So 8 sine 2x. So that'll be another 0. So every time we have a sine, because sine of 0 is 0, those are going to go away. Okay, 4. So I'll get 16 cosine 2x. So that'll be 16. I'll get 32, negative 32, sine 2x. There's our 0. Negative 64 cosine 2x, so negative 64. Interesting. 7 is going to be a positive 120, right? Positive, negative, negative, positive, positive, negative, negative, right? Positive, positive. 128, negative cosine goes to positive. 128 sine 2x, so there's our 0. Last one, and that'll be what, 256? Cosine 2x, so that's 256. Oh gosh, you're right. Who wasn't yelling at me? Divided by 2 factorial. Divided by 4 factorial. Divided by 6 factorial. And divided by 8 factorial, right? That was a big part of it. Okay, So let's go ahead and build up that Taylor, in this case Maclaurin, because that was right a 0. But our 8th order Taylor/Maclaurin polynomial. So my first term is 1 minus 4 over 2 factorial x minus a, but a is 0, right? So it's just going to be x squared plus 16 over 4 factorial x to the 4th minus 64 over 6 factorial x to the 6th. And then finally, plus 256 over 8 factorial x to the 8th. Now, absolutely, you should tidy up those coefficients, but I don't want to take your time to do that here. So you can figure out your factorials, reduce your fractions, and you're good to go. Okay, well, let's do an example where our a is not 0. Well, that seems to be all I kind of focus on because they're so much easier to evaluate. But that's okay. We can do it. So we're going to go a 3rd degree Taylor. A is 1, and my function is x squared e to the negative x. So I need out to the 3rd derivative. So instead of making my table, I think I need to have some workspace to calculate all of those derivatives, right? I'm going to go take it up here. I've got a little space. So let's go up here and find those derivatives. So let's find our first derivative. Why do I think it's going to take space, guys? Right? Got a product. I've got a chain. It's going to take a bit of time. So first derivative is first times the derivative of the second plus the second times the derivative of the first. Okay. So I'm going to make that look just a little bit nicer. So I have negative x squared e to the negative x plus 2x e to the negative x. I think I might actually go ahead and take that one more step, factor out an e to the negative x, and that'll give me negative x squared plus 2x. Yes, yep, I hear you, and I did it on purpose. You're thinking, well, why didn't you just take out an x as well? And I could have, but I'm thinking if I do it this way, my product rule, when I go for my second derivative, isn't going to be nearly as ugly, because this derivative is just going to be a polynomial, right? If I would have taken the x out, I still would have had a product rule, but then out front would have been an additional product rule. I don't want to do that. Okay, so there is first derivative. I'm going to go ahead and box that up. Now we have to go again. We have a couple more times. So second derivative. Okay, so first times the derivative of the second, negative 2x plus 2, plus the second times the derivative of the first. So that'll be times the negative e to the negative x. Okay, so let's go ahead and tidy up that second derivative. And let's see, they both have the e to the negative x, so let's go ahead and take the e to the negative x out in front. And let's see the parts that were left. So I have this negative 2x plus 2. Then over here, I have that negative sign left over that will distribute through that second set of parentheses. Right, so I'll have a plus x squared minus 2x. Okay, one more tidying step. So e to the negative x, let's just write it in standard form. So x squared minus 4x plus 2. Okay, so there's the second derivative. And now let's get our third and last derivative that I need for n of 3. So third derivative. So first times the derivative of the second plus, can I just do the minus because I know it's going to, right, put that negative sign in, plus the derivative of the second times the first. And then last step of factoring out, just making it look nice, factor out that e to the negative x. We don't really need to do it on this one because we're just going to plug in that value, but that's okay. Let's see, who do I have there? I'm going to have a negative x squared. Really? I kind of thought I would have had a higher power. Hold on, let me take a second. Nope, I guess not. Okay, negative x squared. I'm going to have a plus 4x plus 2x, so that'll be plus 6x. And then I'm going to have a negative 4 minus 2 minus 6. If I made an algebra mistake in there, go ahead and fix it on your page, and I apologize. All right, so I have the formulas that are going to calculate our coefficients, and you guys are going to yell at me when I forget to put that over n factorial part, because, you know, you've seen me do it before. So we're just going to do f of n at 1. We'll do it. I'll make its own column so that I make sure to do it. Divide by n factorial. Okay, so we're going to go 0, 1, 2, 3. Right? So if n is 0, we just use our regular function. Right? So these are getting my coefficients. So I'm going to get 0. 0 times 1 is 0. And then over n factorial, still 0. Oh, okay. If n is 1, okay, so now I have to go to my first derivative. Where's that? Up here. Okay. And we're evaluating this at a equals 1, right? At x, so a, this is an x value. Right? So to find that coefficient, I'm going to do f prime of a. So f prime of 1. So that'll be e to the negative 1. Here, let me grab a different color. And it'll be e to the negative 1 times the opposite of negative 1 squared plus 2 times negative 1. I'm being very specific with those parentheses and negative signs. Okay, let's be careful here. So I'm going to have e to the negative 1. Let me grab a little card here. So that'll be 1 over e. And then I have negative 1 quantity squared is positive 1, but then I have that negative sign, so that'll be a negative 1, and then minus 2. So that'll be negative 3 over e for that next coefficient. So negative 3 over e, and then over n factorial. So negative 3 over e times 1. So it's still just negative 3 over e. Okay, good. If n is 2, right? So now we're going to go to the second derivative. Oh, and there's that. So we're going to do the second derivative at 1, right? So we're going to evaluate this at 1 in for all of the x's. So I will have, oh, why did I plug in negative 1? You guys, oh my gosh, you guys, I'm sorry. Let's go back here. A equals 1. A equals 1, positive 1, positive 1. Goodness sakes. So that'll be negative 1 plus 2. Is that better? Thank you. 1 over e, positive, positive, 1 over e. Goodness sakes. Positive 1's e to the negative 1. Take it slowly. 1 squared minus 4 times 1 plus 2. So this e to the negative 1 is going to be a constant thing in there, right? So I'll have an e in the bottom. What do I have on the top? I've got 1 minus 4 plus 2. 3 minus 4, negative 1. Oh. So negative 1 over e for that part, and then divided by 2 factorial. So negative 1 over 2e. Okay, let's see if I can get this next one on the first try. Third derivative. We'll see. So again, 1. Do I have one more color? I got one more color. We're going to put positive 1 in for all of the x's. See what we get. That e to the negative 1 becomes an e to the positive 1 in the denominator, and then I'll get negative 1 plus 6 minus 6. This is me pausing, thinking that my other one should have been negative as well. You guys go back and fix it because, right, you can't trust my arithmetic these days. So negative 1 over e. So I'm going to get negative 1 over e, and then the 3 factorial, so negative 1 over 6e. Okay. Did you guys check the sign on that first term? Our first non-zero coefficient? Tell you what, if it's supposed to be negative, you guys fix that. So here we go. I want to write out that third order Taylor polynomial. So t sub 3 equals. So the first one is going to be 0. I'll go ahead and write it. And then I'll do my plus because I didn't look for my error. So then plus 1 over e. So I haven't done this part before because I've always done Maclaurin. So this is Taylor. A is 1. So it's going to be x minus 1 to the first. And then here comes our second term. So then minus 1 over 2e, x minus 1 squared. And then the last term will be minus 1 over 6e, x minus 1 cubed. So right, there are a couple ways I could check it. I could go back and check my algebra that's causing me just not a small amount of grief. Or I could sketch. I guess I could check my calculus too. Maybe I didn't write that exactly right. Oh gosh, wouldn't that be a pain? Because that mistake would follow me through all the rest of those derivatives. Oh, fingers crossed. If you wanted to check, right, y1 for your original function, y2 for your Taylor polynomial, see if the graphs match near. They don't have to match everywhere. But they should be close around x equals 1.